In the first part of the investigation 2, we were just talking about some basics about scatter plots, how to identify good ones, looking at trend lines, writing equations of those lines. In this portion, we're actually going to create the scatter plots and then continue on. So here, as you see in A, we're going to create a scatter plot, we're going to draw the trend line, and then we're going to write an equation for that line. And here's the data. The data has to do with hours of TV watched per week, percent of homework completed, and the test score. So the question says, is the amount of television that students watch related to how much homework they complete or how well they score on tests? So the following data were collected on 9 students in an algebra class. So this is student 1, 2, 3, and so on down to student 9. If we take a look at, say, student 3 watched 28 hours of television, completed 65% of their homework, and got a 75 on a test. And just for the record, that's 28 hours in a week. That's a lot of television. Okay, so first, let's set up our scatter plot. We have to decide who goes along the x-axis, and again, looking up here, it says that the hours of TV watched per week is going to be our x, and the percent of homework completed is going to be our y. So let's go ahead and label these axes accordingly. Okay, so as you've noticed, I've labeled my axes accordingly, and up here I've labeled the data, and then I've gone and I've actually highlighted the highest and lowest number of hours per week watched of TV. And the reason I did that is if I didn't have this already pre-numbered for me, I kind of want to know, like, 0 to what? And, we could have stopped at 35 or something like that. And again, it's try to make this number system work for you. Don't work for it. Just because we have 19 doesn't mean that 19 has to be one of these numbers down there. This scatter plot is for us to get a ballpark idea. Soon we're going to do all of this on the calculator and get very exact answers. This is sort of guiding us in that direction. Of course, on the percentage of homework completed, 100 down to 0 is a reasonable piece. So go ahead and take student 1. So we're going to call this first student, student 1, 2, 3, and so on, down to student 9. See if you can plot all of these points. So remember, for the first student, 32 is going to be your x value, 58 is going to be your y value. Technically, this whole graph here is all quadrant 1. It's all positive, positive. So plot that 32, 58 and see where that lands. Press pause and try that. Okay, so that first point landed right here. That's 32 hours of TV watched, and over here 58 percentile on their test. If you are okay with that point, then go ahead and press pause and put all of the rest of the points in there. All right, do you have a scatter plot that looks somewhat like mine? If you notice, if you count up all these points, there's 1, 2, 3, 4, 5, 6, 7, 8 points. That's because 1575 shows up twice. So here's 15, and here's roughly 75. And so this point actually shows up twice. Now let's go ahead and draw the trend line in there. And again, the trend line is the one that sort of approximates most what's going on. It doesn't hit every last point. It doesn't underscore them all. It doesn't overshoot them all. Go ahead and press pause and try to draw a trend line in for yourself. I think that's a reasonable trend line. And now let's go ahead and choose 2 points that we're going to use to write our equation. These are the 2 points that I'm going to use. So we're going to find their coordinates and we're going to use those to write the equation. Okay, notice that I've not only identified the coordinates, but I've also given the units. So this is 11 hours of television and a 92% of homework completed, 32 hours worth of television, and 58% of homework completed. So first what I'm going to do is I'm going to take my 2 points and I'm going to identify the slope. Once I have the slope, I'm going to use the slope and one of these 2 points to write the equation of the line. And we're going to talk about what's going on in context. So press pause and work this out. First, calculate the slope. Okay, so what I ended up with was a slope of negative 1.62. And how did I arrive at that answer? Well, first like I always suggest, I labeled my points, wrote my formula, got a final fractional answer. And this fractional answer, after I actually performed the division of negative 34 divided by 21, arrive at this negative 1.62. Keep in mind that that trend line was going down. That means that we're going to have a negative slope. Now let's interpret what it means. This is the most important part. This is the critical component of this whole investigation, is interpreting what's happening. So I look here. My change in rise over change in run is, my y value was percent and my x value was hours. So as we're talking about a negative slope, that means that I would expect, or this model sort of suggests, a negative 1.62% decline in percentage of homework done for every hour of TV increased. So as we're moving to the right on x, it's increasing. And as we increase x, y is actually going down. So it sort of makes sense that if you're going to increase the number of hours of television you're watching, you're probably going to decrease the percentage of homework that's getting completed. That's not good. If you'd like, you could write it as a fraction, negative 1.62 over 1. And as long as you do the division, it's always going to be over 1. And then we have our point slope formula. This is, I think, the superior way to write an equation of a line. So go ahead and choose one of your points. I like the first one, 1192, for no other reason than it was just the first one I saw. And now I'm going to substitute that in and number crunch this down into the final y equals mx plus b, the slope-intercept form of the line. So go ahead and substitute these values in to the formula and give me an equation. Press pause and you work it out on your own. Okay, so here's my final equation, and here's my final equation in context of the real world. Now, notice we have the percent of homework completed would be equal to negative 1.62 times the number of hours a week you watch television, and we are going to add 109.82 to that. So technically, if the hours of homework watched, or hours of TV watch was 0, then we could expect about 109.82% of homework. And you say, well, that doesn't make sense. Sometimes the y-intercept doesn't make complete logical sense in real life. This number right here, your y-intercept, is the sort of correction number that makes the whole trend line work out. But if we substitute in some other values, we should land within reason of what the actual data was. And so let's bring the picture in and I'll explain a little bit further what I mean. So let's say we took 22 hours of homework and put that into our equation. Our equation is going to generate an approximate guess of about 70% of, or 75% of homework being completed. It's going to give you the coordinate of any number on that line. And all I'm asking is that within reason of the original point that was just to the left of that? Would we land within reason of the actual data that we saw? And the answer to that is yes. So what the trend line is, again, is a reasonable interpretation of the data. And that's what we had in the last video. So we're using this trend line as a means to guess other points within the vicinity of the original data that we had. And we're going to talk more about some fancy vocabulary that describes that process. All right, so let's take a look on your handout and see, where we're at with this. At this point, we've already talked about the slope of the trend line, okay? And we already talked about what does the slope mean in the context, all right? So double back if you need to write that in, but hopefully you wrote it in as we were working. Now we're going to use the homework to predict percent of homework completed for a student who watches 24 hours. So what do? We substitute 24 in for the x value in our equation. Okay. So here's our setup. I substituted 24 hours of television in for my x value because that's what hours of TV was per week. And now you crunch out the final number. What percentage of homework would we estimate this to be? All right. Did you get 70.94%? Hopefully. Now, as a coordinate pair, that's 24 hours of TV per week with an expectancy of about 71% of homework completed. So now let's see if that makes sense on our original data. So we're going to go to 24 24 hours of homework, and we follow it up till we hit the line. And when we see that line, we follow it over, it's right at about 70%. So I feel pretty good about my arithmetic, and I'm landing right on. That's what we would predict. And my question is that in line with the rest of the data of our original students, or original 9 students? Absolutely. So this trend line business works. We can use our current trend line to predict other students' percentage of homework completed based on a known value of homework watched in a week. And I know that that's not really all that exciting, but think about real-world opportunities out there to use this for other things. A lot of the times this is used in the financial world to predict things. So we're going to close with the definition of interpolation and extrapolation. They're a mouthful. Okay, so first, interpolation. And inter means, within. So we're going to use our function to predict the value. That's what we did. We used 24 hours to predict the value of a dependent variable, the percentage of homework completed, for an independent variable that is in the midst of our data. 24 hours was the number that we used in that last problem. The fewest amount of hours that we had for homework was 11. The max amount of hours, I believe, was 32 hours. So anytime we use a value like 24, a number that's between 11 and 32, to predict percentage of homework, right? If we're going to use numbers in between 11 and 32, we are performing what we call interpolation, which is a reasonably good thing, and we can feel pretty comfortable that our answer or our guess is fairly accurate. What about extrapolation? Oh, well, then that's when we go outside of the zone of 11 and 32. Say we wanted to guess, well, what happens when a kid watches 45 hours of homework? What happens? That's outside of the data that we had collected, and I can certainly use that, but then my answer, or that estimate that I get out, is not, I don't feel as comfortable about that answer because I'm not sure if the pattern continues. And that was something we talked about with respect to ice cream sales and temperature. So extrapolation is sort of dangerous in the world of guessing values. Using our function to predict a value of a dependent variable for an independent variable that is outside the range of our data. So the bottom line is, when you hear the word interpolation, that's within, and when you hear the word extrapolation, that's outside. It's nice to be able to know those words. All right, and so you should be able to go through the rest of this investigation and sort of duplicate our efforts from this video. Good luck.